Hello everyone, welcome to new lecture on vector algebra. Notes for the lecture can be found below the video. So let's continue with our discussion. Okay, so today we will be looking at addition of vectors. So first thing that we need to learn is called the triangle law. So there is a diagram given here. You can all look into it. So let's say we have this AB vector. So what is this AB vector? If we talk in the physical sense, this is like a displacement, right? If you imagine a particle, it has moved from A to B, right? Okay, so AB vector. And let's say now particle decides to go from B to this point C. Okay, so plus BC vector. So what will be the resultant of these? What will be the resultant, or what will be the addition of these two vectors? So what has our particle done? So our particle has basically moved from this initial position to here and then to this final position, right? So what is the total displacement of the particle? So particle has displaced directly from A to C, right? So this must be the resultant of these two additions. AB vector plus BC vector is equal to AC vector. So you can imagine a vector depends only on the initial and the final point. So let's say this is the initial point and this is the final point. So it doesn't matter which trajectory you choose. So you can imagine it like this. If particle moves from A to B, then B to C, then C to D, and I can ask what is AB vector plus BC vector plus CD vector, and the resultant will be AD vector, because that what the particle has done. It has moved from initial point here to final point here. This is the resultant of addition of all these vectors. So just a trick, so that you do not make a mistake. So if you find a vector ends with, let's say here, B, and it starts with B, so you can cancel this B and you can see the result on the right side, right? AC. Okay, so this can be used in this one also. You can cancel these B's here and you can find AC vector plus CD vector, and then you can cancel these C's here to find AD vector as the result, right? Okay, so let's say I started with LHS and this was my proof. So this is the triangle law. Okay, so let's go look into the NCERT. What else is mentioned there? So okay, so we must make a note and say vectors can be redrawn. Vectors can be redrawn. Okay, so if I have a vector A here, I can redraw this vector anywhere I want to, but only things I have to keep in mind: I do not change the direction of the vector, I do not change the length of the vector. So this is also a vector, it doesn't matter. You can bring this vector from here to here. Okay, so क्योंकि वेक्टर के डेफिनेशन में ही क्या होता है, इट इज जस्ट magnitude plus direction, right? ठीक है, so length cannot change and the direction cannot change, but you can draw it anyway. So for example, if I give you a question like in, let's say, it's just a drawing type of basic question. Okay, if I have a vector here, sorry, b vector here and a vector here, and if I ask you what will be the addition of these two vectors. Okay, so you can do this question. What you can do is maybe, so what is a vector plus b vector? So to do this question, you can draw any of the vectors first. So you can draw maybe, let's say, a vector first, and on the head of the a vector you will put tail of the b vector, and you can redraw here it again, and you can imagine the particle going from here 1 to 2 and then 2 to 3. So it has basically moved from 1 to 3, and this will be the resultant as a vector plus b vector. Nobody is stopping you to draw b vector first. So if you did the addition like this, so you can draw b vector here, and then on its head you can put the a vector, and so particle has basically moved from here to here, and this will be b vector plus a vector. And please see, in this in these both of these drawings, the a plus b vector or b plus a vector, they basically look the same. So we will look into that in the next section here. Okay, so we already have defined, if I have a AB vector, so it is going from A to B, AB vector is negative of BC vector, sorry, BA vector. So why? Because BA vector will be a vector which will start from B and end at A, right? So, okay. So my question is, if in a triangle ABC, a small question, what is AB vector plus BC vector plus CA vector? So you can solve this question in two ways. You can draw it and check. You can draw a triangle ABC, let's say A, B, C. So we have AB vector from A to B, then BC vector from B to C, then a CA vector from C to A. Okay, and in doing so, what has our particle done? So if I had a particle, so what it is doing, so it is saying go in this direction from A to B, then B to C, and then come back from C to A. So the total displacement is 0. The resultant must be null vector. So this is just an inference from the diagram. Let's see how we can write the algebraic proof of that. So maybe I can underline these two. So what is AB vector plus BC vector? So AB vector plus BC vector is nothing but, so particle has gone from A to C, so resultant must be AC vector. Or you can cancel these two B's to find AC vector, right? And we have to add CA vector to it. But we already know AC vector is negative of CA vector, so I can write it as minus of AC, and the resultant will be again 0 vector. Okay, or the null vector. Okay, so let's draw the parallelogram. Let's do the parallelogram law. And also commutative law. So commutative law says कि A vector plus B vector is same as B vector plus A vector, and parallelogram law says if you have two vectors and if you draw both of those vectors from the same point, so now you're not putting one vector on the head of the other vector. So let's say both are co-initial. So this is A vector and this is B vector. So Parallelogram law says the resultant of addition of a plus b vector will be nothing but the diagonal of the parallelogram formed if you redraw the vector. So let me redraw my b vector here. So I can redraw b vector here because it is parallel and it is of same length. So this is b vector. And I can redraw my a vector here, and now it becomes a parallelogram because these two are parallel and equal, right? Parallel and equal, right? So a vector. And let me number these one, so maybe with a different color. 1, 2, 3 and 4, or if you like you can name the quadrilateral as PQRS. So in triangle PQR you can clearly see PQ vector, उसके हेड पे क्या रखा हुआ है, QR vector, and the resultant is so we have moved from P to Q, then Q to R, the resultant must be PR vector. And if I put the values in, so the diagonal is A plus B vector, right? Okay. So we found the value of PR vector, the diagonal. This is the A plus B, and that's what the parallelogram law was saying. And since I'm doing the commutative law in the same derivation, I will also see in triangle PSR. In triangle PSR, you can go from P to R in a different way. PR vector is same as, you can go from P to S, then S to R. Okay, but so PR vector is nothing but PS, which is B vector, plus A vector. So from 1 and 2, we can safely say A vector plus B vector is equal to B vector plus A vector. So vector addition is commutative, or under addition vectors commute. Okay, so under addition vectors commute. Okay, so moving further into this discussion, let's do the associative property. So maybe we can take the property from the NCERT. So it says this is the associative property. So to do this, I'll draw my own diagram. Let's say I want to add these three vectors, A vector, and let's say B vector kahin pe tha, and I put it on the head of A, so B vector, and then some C vector. I want to add these three to find the result. I have already said in the basic sense, the particle has moved from this initial position to this final position, and the resultant must be, if you add all these three, so resultant of A plus B plus C, this must be A plus B plus C, right? But how can we prove this, right? So let's see, and we will also prove the associative property that A plus B can be added first, and then we can add C, or we can add B plus B and C first, and then we can add A. So that is the associative property. So let's see. So इस diagram में I will do a construction. So construction will look like let me do this construction, and let me try to find this length. So you can see A vector plus B vector. So green vector can be found in the lower triangle, and the green vector is nothing but A vector plus B vector, right? Okay. And in the upper triangle, so maybe I can call this PQRS, PQRS. So I'm removing this initial and final. So in triangle PQR, you can see A vector plus B vector is equal to PR vector, right? Okay, so maybe so PQ vector plus QR vector is nothing but PR vector. So we can say PR vector can be found now. PR vector is nothing but A vector plus B vector. And now I can look in triangle PRS, and in triangle PRS, PR vector plus RS vector is nothing but PS vector. So PR, so you're going from P to R, then R to S. This will result in the vector you're going from initial to final position, which is PS vector. And you can find now the PS vector. So PR vector kitna tha? It was A plus B vector, right? So I will put it in a bracket because this is PR vector. And what is RS vector? So RS vector can be seen in the figure. RS vector is nothing but C vector. Okay. So as I said, the resultant is A plus B plus C, but from this diagram we saw it is A plus B in the bracket, then plus C, and we can look into the same diagram again and by drawing a different diagonal. So let's draw again the same diagram. So let's say this is A vector, this is B vector, and this is C vector. And we have to find what is the addition of all these. And we know this is A plus B plus C, but this time I will draw another diagonal. Let's say I will draw this diagonal. Okay, so I will again name the quadrilateral as P, Q, R, S, and I will look into this triangle above. So in triangle QRS, I can go from Q to R, then R to S, and the resultant will be like, I have moved from initial point Q to S, and we can now find the green vector, which is the QS vector. So QS vector is nothing but B vector plus C vector. Okay, so now I'll look in triangle PQS. In triangle PQS, you can go from P to Q, then Q to S, and the resultant will be PS. So look into the diagram. So we can go from P to Q, then Q to S, and resultant will be as you have moved from initial to final point. Okay, so we can find PS vector now. So what is PQ vector? So in our diagram, PQ vector is nothing but A vector. And what is QS vector? We found QS vector is B plus C. So I'll put it in a bracket. And this proves our associative law, and also if you keep on putting vectors, second vector on the head, tail of the second vector on the head of the first vector, and again so on. So you can just join the initial and final point to find the sum of all the vectors. So to find sum of all the vectors, all you need to do is put a vector, you have to draw a vector and put the second vector's tail on the head of the first vector, and if you have a third one, uska tail aap kahan rakhoge? Second vector ke head pe, and you can join the initial and final point to find addition of all the vectors. And we have also proved the associative property. Okay, so hence A plus B plus C vector is equal to A plus B plus C. Okay, so let's look into NCERT. Okay, so there is something called an additive identity. So let's just take it from the NCERT. So what will be the vector that you should add to a vector so that you get the same vector back? Okay, so the question is like, what should I add to this vector so that I get this? Or I can say in the reverse order, but it should give me the same vector back. So for example, in multiplication of numbers, what you can multiply here with the number so that you get same number back. So in multiplicative identity, numbers में क्या होता है? It is 1, right? You can multiply 1 with the number to get the same number back. And what should you add here? So probably we know addition में 0 add करते हैं, and here we add 0 vector. So if you add 0 vector to any vector, you will get the same vector back. It is also 0 is null vector is called additive identity. Okay, so now the next topic is multiplication of a vector with a scalar. Okay, so this is a very easy concept. So let's say we have a vector. So I can multiply that vector with the number. Let's say I can multiply the vector with half. So what will be half of a vector? It will, so since it is not changing, so it's half is positive, so it will not change the direction of the vector, but it will make the length of the vector will become half. So उसका length आधा हो जाएगा, उसका direction change नहीं होगा. But what will be -2 times a vector? So -2 में 2 will signify कि उसका length क्या हो जाएगा? अब double हो जाएगा. So length of the vector will become double. But minus means, so it is in the opposite direction of a. So now it will have the opposite direction, and arrow will be in the other at the opposite point. Okay, so so nothing much is here to which should be difficult. Okay, so now we want to define what is a unit vector before we move to our next lecture, which is component of a vector. So last definition of this lecture is unit vector. Okay, so most important definition. So we already said we can take a vector a and we can divide with or multiply it with certain number, right? We can do lambda times a, right? Okay, some lambda, so lambda is some real number. Okay, lambda belongs to real, and we can scale the vector, right? So what we are doing here is scaling the vector. So what will happen if I divide the vector by its own length? And that will result in a vector of length 1. It will result in a vector of length 1 because we can do the scaling. So अगर मैं किसी चीज को उसके खुद के लेंथ से डिवाइड कर दूंगा, what you will get 1 as the result, right? Okay, and how else we can see that? Well, let's say length of our vector is nothing but some lambda, right? Okay, so if I divide a vector by its own length, so I will get the result as 1 by lambda times a vector, and I can ask what will be the length of this vector. So length of this vector, so will be 1 by lambda a vector, and so 1 by lambda can go outside and we have length of a vector, but we already know what is the length of a vector, right? We already know length of the a vector is lambda, so lambda cancel and length of this vector is 1. So this is how we define unit vector. So so unit vectors generally are used to define certain directions, okay? So they lose the information about what was a vector. They are of length 1. Okay, so length of the unit vector is 1, and this is the proof on the right side. Okay, so this is the a cap, right? Okay, and so what is mod of a cap? Okay, so mod of a cap is 1. So that is the second property of unit vector. So thank you for watching. Notes will be available below, and you can like, share, and subscribe. And I will meet you in the next lecture where we continue with our discussions.